Hi all, welcome back to software testing course. So in the last video we had seen about testing the systems wherein we studied about functional requirements and non-functional requirements. And in the non-functional requirements we had seen three categories of it. Then we had started with the testing strategies wherein we completed static and dynamic testing with examples, and we had already we had also seen why testing is difficult, right? And in this we had seen exhaustive testing. So let's move on and we'll get started with what is a test case. Okay, so when you want to test a particular specification in your software, you have to give certain inputs to it, right? Whenever your software is being getting executed, you have to give inputs to it. So for these test inputs, whatever you give, you expect some result, right? So that we call it as expected result. Okay, but actually the software will produce some output. Okay, that we call it as a actual test result. I'll repeat once again. So whenever, okay, say for example there is a login form, and you have given say for example you have given correct username and correct password for that particular login form, and you are expecting that you will log in successfully. So this is your expectation. You are expecting that you will log in successfully. But say suppose you will not log in, or there is some error on the screen. So that error we call it as a actual output. So expected result is different from the actual result. Okay. So it is not always the case that expected result is different from your actual result. If those two are different, then there is a bug. Okay, if those two are same, if the expected is equal to your actual output, that means the software is working as per its design. Okay, so just before giving the test inputs, the software will be in a particular state. So this initial state is described by the entry criteria. Okay. Then after the testing, software will go into another state. So this we call it as an exit criteria. So your test case, it defines entry criteria, exit criteria, the test inputs, and the expected result. So these all things are represented in this diagram. Okay, this is the executable code, or your a part of code your on from your project. So your project is in some state before giving this test input, so that we call it as entry criteria, that is prerequisites or precondition before your test input is given. So whenever you give test input and execute the code, you will have some result, right? So here we have the exit criteria, that is the state wherein you are after giving the inputs your software will go into a particular state. So that is exit criteria, the post conditions after the test inputs are executed. And however we have the last one, test result, right? So these are the aspects of your test case. Okay, so we'll take an example and we'll understand this one. So say suppose you need to test a program that takes a file name as input. Once the file name is given as input, then what it will do, your program, it opens the file, it writes today's date into the file, and then it closes the file. Now you have to test this one. How do you define a test case for this one? What is the input? What is the entry criteria? What is the expected output? And what is the exit criteria? Right? So first we'll talk about entry criteria. Okay. So in our case, in this example, the entry criteria is, say for example, the file abc.txt. It should not exist in the current folder or the directory. This is some situation, before giving the input to your program. So what is the test input for your program? It should be a file name called abc.txt. Then what are you expecting out of this program? So you are expecting that the file ABC should be present in the directory. It has to be opened and it has to have the today's date into the file, and then the file has to be closed. Okay. Then what is the exit criteria? So the program, whenever you give the proper file name and if the file name is not present in your system, then it should terminate without errors. The file abc.txt, it should be available in the current directory. So whenever you open that file, it should have today's date. Getting it? So the test input, the input for your program is the file name. Entry criteria is that the file should not exist. What are you expecting from this program? Is your file should be in the directory, it should have today's date, and exit criteria is that you should not get any errors and the file should be present in the current directory. Okay, so this is one test case. Okay, so you need to define number of such test cases for testing the specification of your software. Okay, so for example, we'll consider this figure wherein you could see the first one as from the number of test cases, you select few test cases, you execute them, and then you analyze the results of it. Okay, so the number of so we'll consider another example wherein you want to sort a given set of strings. Okay, so the string can be simply letters or words or sentences. So all these possible strings have to be given as inputs and the software has to be tested. Again, it has to be tested or ensured that the software it does not malfunction or it does not crash when a large string is given as the input. So you need to select some test inputs from the set of all possible test inputs and design the test cases. We had seen in the exhaustive testing, right? So if we have n number of inputs to be given to the program, we cannot have or it is not practically possible to give all sets of inputs. So we have to what we have to do? We have to choose some inputs and we have to create test cases, and in that test case we have to execute them, then we have to analyze the test results. Okay, so this designing of the test case, it is the most challenging assignments for the testers. So the test cases have to be designed based on two criteria. It has to be reliable and it has to be valid. Okay, so a set of test cases will be considered as reliable if it detects all the errors in your project or the software. Then we'll check about the validity. That means a set of test cases they are considered as valid if at least one of the test case it reveals the errors that are present in your software. So remember, in test case you have four criterias, that is your test input, entry criteria, expected output and exit criteria. These four things are necessary. Then if you have n number of inputs that has to be given to your software, then what you can do, you can create certain test cases, you can choose best among them, execute and then analyze the result. Again, you have to design the test case in such a manner that it should be reliable and it should be valid. Now we will talk about two more things, that is pesticide paradox and defect clustering. Okay, so first we'll talk about pesticide paradox. So in 1990, Boris Bezer he used the phrase pesticide paradox to describe an interesting phenomenon in testing. So this means what is pesticide paradox? Yeah. So whenever you use the same test cases to test the software, you cannot uncover the defects. It is something similar to using the same pesticide again and again to the same insects, right? So if you use the say suppose there are some insects that are in your home and you use some pesticide on that, so one or two times those will be killed. So if you use the same pesticides again and again to the insects, they will be immune to that particular uh, pesticide, right? So your software is also something similar like this. If you use the same set of test cases again and again on the software to execute it, you may not uncover the defects. Okay, so it is not a good strategy to repeatedly use the same test cases. So that means you have to keep changing on your test cases. So this is pesticide paradox. The next one is defect clustering. So in a software package which consists of a number of modules, it is likely that the defects cluster in a module or a function. Cluster means group. Okay, so whenever you have a package or the software which has n number of modules or functions in it, it is most likely that the defects will be it will be present in a function or a module as a group. Okay, so when you encounter defects in that module, you keep testing the module more rigorously by choosing a large number of test cases that can test that particular module. So this can happen due to various reasons. That is the why a particular function or a module it has many defects. Why? Because the developers who worked on that module would have not he has got necessary expertise, or the module would have been more complex, etc. So whatever may be the reason, if you find a good number of defects in a module, thorough testing of the module is must. So more test cases need to be selected to test that particular functionality of the module. So this is defect clustering. Next we'll move on to test oracle. So oracle is a repository of knowledge. Okay, the meaning of oracle is repository of knowledge. So in the earlier days, people used to go to a place known as an oracle where the god is depicted in the form of a statue. So the people go beside the statue and convey their problems, and the god, okay, actually the priest who used to hide beneath the statue, he used to answer the person and give the solution. So something similar would happen in the test oracle. So your test oracle are the people or the machines that check the correctness of the program for a given test cases. Okay, so this is a diagram for test oracle. So as you could see in the diagram, first the test cases are given as input, and those would be executed on your software, okay, or the project. Who will test that? It would be tested by a test oracle. This is a machine or a human oracle. Then the results would be compiled. Okay, so this is the work of your test oracle. That is, these are the people or the machine that check the correctness of the program for any given test cases. So human test oracles are used extensively. If the program does not work, a common way is to give a program whatever you have written and the input test data to a friend and ask him or her to check for the output of the program. So your friend now acts as a computer. That means he goes through the code step by step as per the input data and arrives at the output. Now, if the output is same as the expected, then the program is said to be correct. Otherwise, there is a defect in the software. Okay. Many projects are now being undertaken which are for replacing an old system with a new. The old system may be your manual system or a software based system. Okay. So when the new software is developed with the same functionality, you can compare its output results with those of the older system. So if the results match, then you can say that the new software is working okay. So in this situation, our old system will act as a test oracle. So for example, we'll consider a manual system which is currently present. Say suppose student registration in the college, right? So right now it is a manual process, and say suppose you want to automate it, right? So whenever you automate those things, so you check the correctness of the new program, whatever you have automated, along with that of, or you compare that with of your manual system. If both are working correctly, that means whenever you compare the expected and the actual, if both are working properly, that means whatever you have built is correct. Otherwise, there is a problem in the software. Okay. Next, we'll talk about test software. Okay, so the test engineers, they need to appreciate that the environment in which the software is being developed, it will be different from the environment in which the software will actually perform, or in which the software would be actually tested or used by the customers. So in such cases, you need to simulate the actual working environment in your laboratory. So how this can be done is by using of your simulators. So, for example, we'll consider say, suppose you need to test the software that has to work on a satellite based computer network. Okay, so since you do not have access to a satellite based network, what do? You simulate the environment on a LAN or by interconnecting the computers using serial communication links. So, this setup we call it as a simulator, or the same setup which is similar to your network based computer network. So, the same thing we'll do it in our lab. Okay, so you need to write some additional software to simulate the long delays in the satellite network. So if the software works in a simulated environment, so if it works right, then you get some confidence on the software that finally it might work on the actual environment. After that, what you have to do whenever you gain the confidence, or whenever you are done testing in the lab, so you need to do a field trial testing. So, what is this field trial testing and all? We'll see in the next chapter. Okay. So, understand here, whenever you have completed testing in a simulator in your lab, then you have to do a field trial testing by installing that software on the actual satellite based computer network, and you have to test it. So, I'll give you another example. Say, suppose you want to test an embedded software that has to be ported on an ARM processor based hardware module. So, if the module is not available with you, you need to test the software on a PC using the cross platform tools and emulators supplied by your embedded software vendor or the processor. So, again, it is nothing but test on the simulator first, then do a field trial. Okay, we'll take another example. So, say suppose now you have to integrate your software package with another software which is being developed by another organization. Okay, uh, some piece of the project would be developed by your organization, and some piece of the project would be of the same project would be developed by different organization. Now you want to combine them, integrate them. So how can you do that? So when your software is ready, you write a special software that gives the necessary inputs to the other software package or the other code. So, in other words, you are simulating an environment in which the subsystem can be tested, or their other organization code can be tested. Now, this is called as test harness. Okay, writing test harness is also part of test engineer's job. So, testing the unit and the components is difficult for the developers, but they have to do this one. Additional code has to be written for the units and the components. The test software, those additional softwares, what we write. So, either it may be drivers or stubs. Okay, so what is test harness, drivers, and stubs? We have already seen this in the last semester. Okay, next we'll move on to manual versus automated testing. Okay, so for many years software testing was done manually. Even now few they are doing the testing manually itself. So in the manual testing, what is the job of your tester? So what are the things he will perform? So first thing is like he has to understand the requirements, that is your SRS, and he has to understand the design of the project. Hmm? So once he understands the specifications and the design properly, he can come up with the test scenarios. Okay, so once the test scenarios are identified, like what are things to be tested, okay, so then the tester or the test engineer will start designing the test cases, or he'll start writing the test cases. So for each test case, he has to ensure that the necessary test setup is available and the entry criteria are met. Okay. Then once the test cases are ready, so he has to jot down the test inputs. What are the inputs that can be given to that particular test case? Then he has to execute the test cases. So he has to check whether the test results, that is the actual results, whether they are matching with the expected results or not. So if there is any deviation, that means if your actual is not equal to your expected result, then there is a defect. The defect has to be entered, the details of the defect along with the screenshot, result, everything has to be maintained in the database or whatever the tool, defect tracking tool is. Okay. So once all these things is done, again he has to repeat the entire process for all the test cases. You have to remember here, whenever the defect is found and it has been reported, again it is the test engineer's duty to check whether, say suppose the defect has been found out, and the tester he has entered the details in the test tracking tool or a database. Okay. Now it is the developer's duty to fix that particular defect, and once the developer fix the defect, it is again the tester's job, okay, to retest the defect and mark it as whether it's working or not. Okay. So whenever the manual process was there, so the test engineers or the testers had to follow, or they will follow these all steps. So this manual testing, it has lot of problems. So what are the problems, right? So every time the testing is repeated, manually entering the data, it becomes very boring, and it is likely that you make mistakes in the data entry. So again, comparing the actual results with the expected results, it may also turn out to be boring for many types of testing. Again, entering the details of the defect each time is again a very tedious task. Okay. So there is a lot of repetitive and unproductive work that can be easily automated using the software testing tools. So nowadays a lot of commercial and open source tools are available, so those can be used for carrying out your functional and performance testing. Tools are again available for managing the entire testing process, from managing your requirements to the test cases, the execution along with the defect, entire process can be automated. Okay. So specialized testing tools are used for, again, your testing of the embedded system, networks, etc. Fine. So these tools will study in the future chapters. Okay. That's it for today. We'll conclude our session. Thank you.